All right, so let's start with quick sort. And I thought we'd start with the applet demo today a little bit. Then we'll go to the book, and then we'll come back to the applet and look at it again. And then I thought we'd watch a video on quick sort, and then I thought we'd do a little quick sort with our cups here. Okay, because quick sort's a little bit more complicated than the simple sorts. Okay, so just to kind of get an idea of what quick sort is, here's our applet. Okay, notice that we have a couple of pointers here. I'm just going to run through him, so he's just going to run. But notice that we have a left pointer that's red, a left scan that's blue, a right pointer that's red, and a right scan that's blue, and then we have this pink pivot. Okay, those are all pointers to indices in our array that we're sorting. Okay, and so if I hit run, okay, lots of things are going on in here. Okay, it's kind of demo, yes. It's kind of hard to see what's going on at first. Okay, so we're going to have to look at this a little bit more carefully than the other sorts. Okay, notice that it sorted pretty quickly. Okay, compared to the other sorts, quick sort is a lot faster. It's an n log n algorithm compared to our worser algorithms, or n squared. Okay. So I'm actually going to go to the textbook at first here. All right. So hopefully you've kind of read through this a little bit. You know, this is on chapter 23. This is our figure 23.8. And it kind of shows, one pass through a quick sort. And so what quick sort does is it picks what's called a pivot point. Okay? So anything lower than the pivot point is going to go to the left of the pivot. And anything that's bigger than the pivot point is going to be moved to the right of the pivot. And so in that manner, everything that's smaller is getting moved to the left, and anything that's bigger is getting moved to the right, and then we just keep on picking new pivots, and then at the end he's sorted. Okay? All right. So you can initialize your pivot to anything in your array. Some algorithms initialize the pivot to the thing that's in the middle of the array. Some algorithms are a little bit smarter and find the smallest or the middle integer and decide that that's the pivot. The algorithm in our text does something really simple. It just says, okay, the first number in the array is our pivot. Okay? So he just chooses that first number as the pivot. So he chose number 5 as our pivot. Okay, so we have this array of unordered values, and it chose number 5 at index 0 as our pivot. Then it has a low pointer and a high pointer. The low pointer points to the second item in the array to start with, and then the high pointer points to the last item. That's pretty easy to understand, right? Now we're going to search forward and we're going to search backwards. So the low pivot and the high pivot are both, or not low pivot, the low pointer and the high pointer are both going to move. Okay? Low pointer is going to keep on moving over till it gets to a value that's bigger than 5. So he's in a while loop, you can think, and he's comparing everything to 5, and when he finds a value that's bigger than 5, he stops. Okay? And then high pointer starts at the end, and he compares everything to 5, and when he finds a value that's less than or equal to 5, he stops. Okay. Now when they're both stopped, what do they do with those values? They swap them. Okay. And then they move on again. So low pointer will move again. He's comparing everything to 5. He compares 3 to 5. He compares 8 to 5. 8 is greater than 5, so he stops. High moves down again. He only moves one space. He says 0 is less than 5, and he stops. And then what do they do again? Yep, they swap. Okay. That's pretty easy, right? Now when they get here, so low is moving on. 4 is less than 5, so he doesn't stop. He stops when he gets to 8. High moves down again. He stops when he gets to 4 because 4 is less than 5. But now they've crossed. When high is less than low, or low is greater than high, the search is over. Okay, so that signals to us when we should stop. Okay? And what do we do when we stop? What did it do? It switched the pivot with the high. And now everything to the left of the pivot is less than pivot, and everything to the right of pivot is greater than pivot. Pivot is in the correct location now. Okay? Now it'll do the same thing to this array. Okay, so it takes this array as a new array, sets this as the pivot. This will be low. This will be high. Okay? Your book stops right here, but we could continue on the board if we want. In fact, this will be good to continue on the board. Okay? Or actually, should we do it in Excel? Let's try it in Excel. I used to go to the board all the time, but let's try it in Excel. Come here. Mr. Excel, there you are. Okay. So we'll recreate that array. So we have, I'm going to recreate the one at the bottom here. So we have 4, 2, 1. 3, 0, 5, 8, 9, 6, 7. And this is a cool way that you guys could do this at home too when you're learning these things. Is you could draw them out in pictures. So, and we'll put our indices here just to write our indices. And then we'll center everything. And then we'll make these bigger. And 5 was our pivot before, so he's in the correct location. I'm going to fill him up with a certain color. Okay? And then we're going to have our pivot pointer. Okay, and then we'll have our low, and then we'll have our high. And just to make him user-friendly, we can change their colors really quick. All right, so following the algorithm in the book, more. So they only took their picture to here, which I thought was a detriment in the book. Okay, they showed all the good steps and then they stopped. Okay, so we'll continue the steps on right here. So how does the rest of the array get sorted? Okay, 5's in the right place. So what you do is you're going to sort this guy as a new array and then this guy as a new array. It does use recursion, and I know we're not getting to the chapter on recursion until next week, but we can still understand the algorithm. So it sorts the whole array at first. Well, it sorts with that pivot 5. Then it takes this array, and now it's going to repeat this process. So the first element in the array is going to be our pivot. So number 4 will be our pivot. Where does low start out as? Do you guys remember? Yep. It starts at the second index. So it starts at index 1. And then where does high? He starts here. Okay, the last index inside of this mini array, okay, the subarray. Right. So what do? I move low that way till I find something bigger than pivot. Okay? So 2 is less than pivot, 1 is less than pivot, 3 is less than pivot, 0 is less than pivot. Finally, it gets to 5. Wait. Yeah. So low moves up until something is greater than pivot. But I've passed my condition. High is now greater than low. I mean, less than low. High is now less than low. Okay? So what happens when high is less than low? To tell you the truth, the code will move high down this way. It'll see that 0 is less than him, and then it'll say, okay, yeah, 0 is less than 4, I stop. But then that while loop will say, okay, low is greater than high or high is less than low, I need to stop. Okay? So nothing gets switched on this pass. So what will switch at the end? Yep, you switch pivot with high. Okay? So whatever high was, that's what you switch. So the 0 will come here. You're doing a little swap. You guys should all be familiar with swapping now. Okay? And now the 4 is in the correct location. So it starts again. It takes the subarray. Now, normally they won't always be next to each other like that. It just happened that those were. Okay? So now pivot is 0. High is pointing to the second element, okay, inside that subarray. Oh, no, sorry. Low is pointing to the second element in the subarray. Otherwise, we would do our condition. And then high is pointing to the last element in the subarray. Okay. All right. So we move low down till we find something that was greater than pivot. And is 2 greater than pivot? Yes. 2 is greater than 0. So he actually just stays right there. He doesn't have to move anywhere else. And then we move high down till something is less than pivot. So we're going to move high down. Oh, wait, nothing's less than 0. So actually high becomes less than low. So what happens? We stop moving our high and low, and we exchange high with pivot. So 0 is in the correct location. And then we do the subarray again. Okay, so notice that once we understand the process, it's kind of easier, right? Are we starting to understand? So here's our subarray again. You just keep on taking smaller and smaller subarrays till you have one element left, right? Okay. So pivot is our first element in the subarray. Low is the second element in the subarray. High is the last element in the subarray. Okay. We move low down till we find something bigger than 2, okay, than the pivot. So we move this low pointer. 3 is actually bigger than 2, so it stops. And then high moves down, right, till it finds something less than the pivot. It moves down 1 and notices that 1 is less than the pivot. 1 is less than 2. So what does it do when, so what did we do right there? Well, we would have, but what happened? High is less than low. Okay, so what happens when high is less than low? Pivot and high switch. Okay, so pivot and high switch. So, you know, it would have switched them if low wasn't greater than high. Okay, but because they crossed each other, once they cross, you're not going to exchange high and low anymore. You're going to exchange high with pivot. Okay, so you exchange high with pivot. So this will be a 1, and then this guy will be a 2. Now pivot was right here. Pivot was our 2, so he's in the correct location now. You have to remember who your pivot was. And then you do this subarray. But what happens when there's one thing in your subarray? Yeah, he exchanges and then he's in the right location. Okay, so when there's one element in your subarray, he's pretty much in the right location. So then it moves up here to this subarray. Okay, so then he's in the right location. Oops, dang it. I did the wrong thing. I need to make him blue. And then it comes back up here because it is using recursion. And it does this subarray. Okay, so this subarray, 8 is our first element in the subarray, so he's the pivot. Low is the second element in the subarray, he's low. High is the last element in the subarray. We move low down till we find something bigger than pivot, which he already is bigger than pivot, so he stays right there. And then we move high down until something is less than pivot, which 7 is less than 9, so guess what? He stays right there. And what happens? They haven't crossed yet, so what happens? Now you switch low and high, okay, because they haven't crossed each other yet. So remember, low was moving down, but he didn't have to move down very far. He just had to stay right there until he found something greater than pivot. And high was moving down until he found something less than pivot, but they just happened to be in the right place, so they exchange. So this will be a 7. This will be a 9. Okay. And then you keep on moving low up again. So low will move down until he finds something greater than pivot. And high, or low will move up, I should say. And high will move down until he finds something less than pivot. But what happened? They crossed. Okay, so when they cross, what do we do? Exchange pivot with high. Okay. So the 6 gets exchanged with the 8 here. And 8 was our pivot, so he turns blue because he's in the correct location now. Okay, you kind of see how this is working? And it is getting sorted. Actually, it is sorted right now, but he doesn't know it's sorted until he does all his steps. Okay, we can assume that we know the steps now, and we can kind of skip ahead real fast, right? But pretty much, okay, low is going to be pointing to the same place high is actually. So we kind of assume that, hey, we know that this guy's what's going on, right? Hopefully we know. And he is sorted. But he would sort the 6 and the 7 first, then he would sort the 7, then he would sort the 9. Okay? All right. So our steps were, and we can look at them in the book again, just so we know. We pick our pivot, we move low that way till we find something bigger. We move high this way till we find something lower than our pivot. Then we switch them. We keep on repeating that. Low keeps going that way, high keeps coming this way. Switching if we need to until they cross. Once they cross, we exchange pivot with high, and we leave pivot alone now. He's sorted. And then we have the subarrays. All right. All right. And just so we know we got it, I'm going to show this video. I like these videos. So I think we've seen the Hungarian dancers before, right? Yes. In this class, yes. So our great Hungarian dancers are going to do a quick sort for us. In fact, let me turn up the volume. We need some music. So this is your guys' final. You have to learn how to do this dance. Just kidding. All right, so they have their values on there. Did they already? Oh yeah, so the pivot guy has a pivot hat on, right? Oh no, this guy's the pivot. Actually, they're doing theirs a little tiny bit different. What number is that guy? He's a 3. So when he gets to the 8 there, guess what's going to happen? So instead of keeping the pivot in the right place or in the same place, he is the low pointer. Okay, so he is switched each time. But watch, he will be sorted now. So it's still using recursion. It breaks it into the subarrays. So our pivot and low pointer is 2. So they just combine the pivot and the low pointer into one person. Okay? He's sorting with himself when he was holding the hat. Okay, so there's our low pointer and our high pointer, and guess what they're going to do? Of course, they're going to switch, right? And note that 0 is not sorted all the way yet. They only get sorted, like the recursive base step, is when it's one element in the array. So he's not truly sorted until he becomes, until they dance with themselves. So note that it is the same algorithm, and you guys can see that, right? They're just moving pivot each time instead of letting him stay still. So who's going to be sorted at the end of this pass? You guys know who's going to be sorted? Which number is going to be the sorted one? You should know by definitely now. Yes, 6 is going to be definitely sorted, right? So who's our pivot right now? So they still pick the first element in the array to be the pivot. Okay. Who's going to be sorted at the end of this guy? You have to say it before he grabs the other hat. Because 5 was our pivot, so you know that he was going to be the one that's sorted. I guess we can kind of assume that these guys are going to get sorted. And I guess remember this last step when we go and look at our code. because it is using recursion. You'll note that when they become one element in the array, that it is the base case. Okay? Yay, they're sorted. Okay, cool. All right, so they did a little tiny bit different, but their pivot was just combined with their low pointer. Okay. All right. So what I was going to attempt to do now, to make sure we understand this thing, is we're going to attempt to do it with our cups here. Okay. And you guys have to tell me how it goes. Maybe I'll move this thing. You see the cups? Now we can see the cups, right?
Yeah, very.
Oh, it needs to be down more?
That's good, I think.
Okay. See how this comes out. All right, so we have our array. Have 7 cups here. They should be out of order. We got our pointers. All right, so you guys have to tell me what to do. Otherwise, I have to pick one of you guys to come up here. Okay. So where do I put Mr. Pivot? Do you remember? Okay, yeah, they always put him on the first. Now remember that we could pick a different pivot, and you'll see different algorithms online, and they choose maybe a better pivot. But just to keep things simple, your book always chose the first one. The one on the Hungarian one always chose the first one. So it's just simple. And then we have our right pointer and our left pointer. So this is our low and our high. I guess I could make these low and high instead. So where does low go? Yeah, good. Yes, it should go right here. Hopefully you said right there. Okay, good. And then where does our high pointer go? Good, yes. Okay, good. What do we do?
The low goes up and checks the fits.
Right. First off, we compare these guys. And we're finding one that is bigger or smaller than him?
Bigger.
Bigger. So is he bigger? Yeah. Okay. So he stays there then. Okay. And then we compare these two, right? And what are we looking for? Lower than 1. And I think 1 is our lowest. Okay. So we're going to go through the whole process. So what do we do? If it's lower, if it's higher and not lower than 1, what do we do? Right. He compares these two. He compares these two. He compares these two. He compares these two. And when, here, let me check our code. If they're equal or less than or greater than. So if we look at our code, if high is greater than or equal to the pivot, so it actually goes to the pivot. So he goes all the way down to pivot. But now our while loop is false because low is now greater than high, so we stop. Okay? So then what do? Yeah, we switch pivot for high, and then we pull him out. That's our designation that he's not part of the subarray anymore, okay? So then we start over, right? Pivot goes here, low goes here, high goes here. Okay, so what do we do? Right. Oh, I just so happened to pick the highest one next, but that's okay. We still go through the process. So our pivot is 13. We're going to move low till we find something bigger than pivot. So we compare these two. Compare 13 to 3. It's not.
They're the same.
If they're the same, then let's see, in our code. I'm looking at our code here to make sure I remember this correctly. It just checks for the greater than the pivot. Oh, so it does check for equal then. So if they're equal then the low still moves up. Okay? All right. Just wanted to make sure before I said it. We'll go to our code in our book. I'm sure you could program it different ways, but all right. So we're still moving low down. I mean low this way, low up. Okay, so we're looking for one that is bigger than 13. And we get all the way to the end. And nothing's bigger than 13. Okay, so what do we do?
Checks if the high is lower than high pivot.
Yeah, actually you check if the high is lower than pivot. Okay. Well, did he move all the way past him? Actually, low is moved past high of pivot. So actually our while loop will fail right here. If we look at our code, okay, and we can even look at our code, while high is greater than low, so while low is less than high. Oh yeah, so once they've crossed that boundary, it does stop. So each of these while loops that are moving the low pointer and the high pointer, I know this is kind of hard to see. Let me zoom in. Will let me zoom in. I'll use my magnifier. So this is your code from your book. So notice where we're moving the low pointer and the high pointer here. It actually says while low is less than or equal to high, keep moving on. And the high, where the element at high is greater than pivot. But we're actually up in the low one. While low is less than or equal to high, and the element that it's pointing to in low is less than or equal to the pivot. But note that we just keep moving low up, and low does actually move beyond the bounds of our array and does make that while loop false. And then when it gets to this one right here, this is false. Okay, so it does jump out of there and stop right here. So then what do? We go to the next step. If high is greater than low, we swap. You guys should be very familiar with the swap code. Okay, you guys should know your swap code. So we swap. And he is now in the correct location, not him. The pivot is now in the correct location. Okay, everything to the right of him is less than pivot, and everything to the left is greater than pivot. And he was the biggest element, so it makes sense that he got right there. And then we have our subarray. So now he is the pivot. This is our low pointer, and this is our high pointer. Okay. All right, so then what do? We move low pointer this way until we find something bigger than pivot. Okay. So low pointer, it compares, 9 to 5, 9 to 3, compares 9 to 7, nothing's greater than pivot yet, till it gets here. Okay. 11 is greater than 9, so it stops. Now, do we move high pointer down? Check your code. While low is less than or equal to high, is he less than or equal to high? Yes. Okay. And the element at high is greater than pivot. Okay. So we're going to move this guy down.
that's the where you put the high and
And then high will move down. List high is greater than pivot. Yeah, so while list high is greater than pivot. So high is greater than pivot right now. Okay, you're greater than pivot. You are going to move down until we find something less than pivot, and that while loop will be false now. Now note that the second while loop is false. Low is now greater than high. So what's going to happen? If we look at our code, we get to here in our code, if high is greater than low, we swap. Okay, so is high greater than low? Yes, we swap. Okay, so we swap. And what do we swap? We swap high. Wait, high is greater than low. High is not greater than low, sorry. Notice what it was swapping. It's swapping high and low. I'm like, wait a second, that's not right. Because high is not greater than low. High is less than low at this point. We can look right there. He's on this side of him. So what do? Yeah, we swap high with pivot. And you can see that up here. Where is he? Dun, dun, dun. Right here. Here's where we swap high with pivot. Okay? So we swap the high with the pivot. Where's Mr. High? And then he is our pivot, so he's in the correct location. Okay. This is a little bit more complicated, but it does make sense, right? All right. All right. Then now we can do it in different orders, but okay, we're going to do this subarray here. So here's our pivot, here's our low pointer, here's our high pointer. Okay. So what do? Yeah, we check low and pivot. And we want to find something bigger than pivot. 5 is less than pivot. 3 is less than pivot. It moves outside. Okay, so now low is greater than high, or high is less than low. So what do? Yeah, you switch high and pivot. When that fails, when these two cross, is when you switch the high with the pivot. And then your pivot is in the correct location. Got a new use for golf tees. Okay. And then you repeat. So this is our pivot. This is our low pointer. This happens to be our high pointer at the same point. Okay. He's the next index and he's the highest index. But we're going to move low first. Okay, so obviously low is actually going to stay there. High is going to move down. They've crossed. And what's going to happen? Right? They switch, but that's when the two Hungarian guys had the same hat on, or he was dancing with his hat. Oops, dang it. He was dancing with his own hat right here. Okay? So then he's in the right location. And then we move here, and they just happen to all be in the same place. He's dancing with his own hat. And then they move down here. With recursion, they'll move back down here. He dances around with his own hat. And they should be in the right order. Yay, we did it right. Okay. Should we do it one more time? Let's do it one more time, just to make sure we kind of know our quick sort. And he really isn't that bad once you know him, right? He just has a lot of steps. He's more steps. And note how much more efficient this is. This is actually a lot more efficient than our other sorts. Okay, it works tremendously faster.
So when we have it sorted in reverse order, is that when it's going to take the maximum amount of time for this one?
Let's see here. If he was in reverse order, actually we'll try that next. Okay? Let's try that next. All right, but let's go through this one kind of faster. Right, he's the pivot. He's our low. He's our high. I'm not even going to look at the numbers, okay? You guys tell me. Should I move that guy over? No, okay. Should I move this guy over?
Yes. All the way. So what?
Oh. So he keeps on moving, right? Keeps on moving. Okay, and now they've crossed. He exchanges with himself. He's in order. I didn't look at them. He just happened to be there. Hopefully I didn't do it the same. Okay. Okay, so then we have pivot, low, high. Should low move over? Can you guys see the numbers? This is our pivot. This is our low. He stays there? Okay. Here's our high. Here's our pivot. You're finding something less than this guy. Is he less? Oh. See, I'm not even looking. Okay, so then what do? They haven't crossed. They swap, right? Okay. And then he continues on. So he... Oh yeah, so he's comparing him to a low pointer to him. Is he less than him? So he stays there. Okay, he's comparing high pointer to him. Is he... Or no, we want it to find something greater than him, right? Low pointer's looking for something bigger than him. Is he bigger than him? No. So he moves over. Is he bigger than him? Yes. Okay. High pointer moves down. He's looking for somebody less than him. Is this guy less than him? Is this guy less than him? All right, but now they crossed. Uh-oh, they did the crisscross. So what do? Yeah, we swap pivot and high. And then we mark our pivot to know that he's in order. Okay. We can assume this guy's dancing with himself and he's in order. Okay. All right. Ta-da. Okay, so here's our pivot. Do we move? Is this guy greater than pivot? Okay, so he stays there then. Now we're looking for someone less than pivot. Is this guy less than pivot? Is this guy less than pivot? Is this guy less than pivot? Oh, they crisscrossed. Okay, so they crisscross, swap itself. He should be in the right order now. I should have actually looked at them when I mixed them up, but that's okay. But this kind of shows you what it works like. So here's our pivot. Low pointer is going to move this way till something's bigger than pivot. He's bigger. Left, or high pointer is going to move this way till he's less than pivot. They stay? Oh. Now this guy stays? He can't be greater than and less than. They crossed, so he dances with himself, and he's now in the right place. Oops. Now pivot, low and high are pointing to the same place, or actually pivot's over here. Okay. So we're going to move the low pointer till something is bigger than pivot. Is this guy bigger than pivot? So low pointer moves. Crisscrossed. So we exchange pivot with high, and voila. Actually, this guy gets sorted, and then they all move here, and then this guy dances with himself, and then he's sorted. Okay? All right. So it's not that bad of a sort, right? We can kind of get this thing. You guys can be able to do this at home. You can show your family. Get some cups. You should. All right. They might like this one. Tell them it's quick sort. Makes them smarter. Okay, so that's quick sort in a cup. Okay? All right. So hopefully now when we look at our code, quick sort, we could be able to read our code better now, right? So notice I was kind of looking at our code when we were running this thing too. All right, so you should be able to kind of read this code now. In fact, let me copy and paste this into Excel, or not Excel, into Eclipse really quick. Or maybe we could just look at it here. Because it's going to copy all the numbers. So let's just take a look at our code really quick, and then I'm going to have you guys do a class assignment. And we're not going to spend a huge amount of time on this code because I'll expect you guys to kind of look at it at home also. Okay, and then when we get to recursion, we can look back at this quicksort code too. Okay. All right. So let's just look at our code. Now it does use recursion. Okay. So you can see that quicksort, the method takes in a list of integers, so an array of integers, and then it actually calls an overloaded method that takes in the list. And then the first pointer, this is our low and our high. Okay? And this is where it does the recursive stuff. And I know we haven't gotten to recursion. We're getting to recursion next week. But recursion pretty much is a method that calls itself. Recursion is always more inefficient, but in this case, sorting becomes more, I guess the algorithm itself is more efficient than our simple sorting algorithms. But the recursive part is more inefficient. It does use a lot of memory. Okay? All right, so this does tax your computer because he does use a lot of memory. Every time this method is called, new variables are created. Okay, so it does use a lot of RAM to run this thing. All right, but you should be able to read this part of your code. Okay, this is what we just went over. We make our pivot equal to the first element in the array. We make the low be an index to the second index. We make the high equal to the last index in the array. Okay? This is where our high is greater than our low. Remember when that failed, we switched the pivot with the high. Okay, so this little while loop you can think is taking care of when they cross each other. Okay, so once they cross, we'll get out of this while loop. The first part is another while loop, while low is less than high, and the item at low is less than the value pivot. Okay, so that's moving our low pointer that way until we find something bigger than the pivot. This one is going to search backward from, this way. And he's going to move the high pointer down until he finds something, what? Something less than pivot. So notice he stays in the while loop while he's greater than pivot. And once you find something less than pivot, he gets out of there. And now we have our high set to something less than pivot. So first we move our low pointer, and then we move our high pointer. Then we check if they've crossed. Okay? If high is still bigger than low, it means they haven't crossed, right? Okay, so if they've crossed, then high would be less than low. But If high is still greater than low, that means they haven't crossed. So what do? We swap the high element with the low element. Okay? And note that this is that first while loop. Okay, so this while loop will keep going on, swapping the high with the low until they cross. Once they cross, what do? We swap pivot with the item at high. Okay. Now note they have another little while loop here. Well, high is greater than the first and list high is greater than or equal to pivot. Okay, so that's still moving pivot down or high down a little bit, but that's okay. But you should be able to read this code much better now. Kind of get this code, how it's working. It is a pretty cool algorithm. Okay. It does work in n log n time. So if you look up your simple sorts online, you could see him compared to the other. So if you look up your sorting dash algorithms, our website that we like, so remember, you can look at quick sort compared to these other simple sorts. These were our three simple sorts. Remember those? And here's quick sort, so just focus on quick sort and our simple sorts. You can see the recursion in quick sort. And look, quick sort's already finished. And our simple sorts are still working. Okay, so much faster than our simple sorts. All right. Quicksort is a beautiful sort, right? Hopefully you think so. Think about all the hours somebody went into thinking of that one. Yeah. All right. So I'm going to pause this now because I'm going to have you guys do a class assignment. So here's what you guys got to do. Here's an array, but he's already sorted, so let's unsort him. So we're going to make two unsorted arrays. So your input to your method, okay, is going to be two unsorted arrays. Here's our first unsorted array. And here's our second unsorted array. And let's give him new numbers so he can be different. All right, so here's our two unsorted arrays. Now, they don't have to be the same size. They could actually be different sizes. So if I wanted to make them different sizes, let's make this guy a different size than him. So they just have to be two unsorted arrays. And you're going to give them as parameters to your method. Okay? So let's think of the algorithm we're going to use. We're going to combine these two arrays into one sorted array. So first off, the first step in your algorithm when you write this thing will be to make a new array to put all the new elements into. So what size is it going to be? What size is your new sorted array going to be? Right. It'll be the number of elements in array 1 with the number of elements in array 2. Okay, and if they're filled all the way, then it would be this guy's length plus this guy's length. So in this case, how many elements is it going to have? Good, 18, yes. Because remember that this guy has 10 elements and this guy has 8. Okay? So he's going to be 18 elements long. So let me format my painter. We'll paint a new array here. And then let me copy my indices. And we'll index a new array up here. Oh, we're one short. Well, actually, that's 18, right? Hey, I happen to make him the right size. And we'll spread them out a little bit here. All right. So your first step in your algorithm, make a new array. That's the length of the first array plus the length of the second array. Now what's going to be your next step in your algorithm? And I'll give you a hint. You're going to have to keep track of where you are inside of your arrays. So you're going to have a couple of pointers in here. Okay? So you'll have a pointer here. I don't care what you call him. He could be blue. And then you'll have a pointer here. He could be orange. And then you can have another pointer over here. And he can be yellow. So we'll just do it with colors. All right, so what do we do? The next step in our algorithm, what do we do? So first step, make a new array. Maybe the second step was make these pointers point to the first index in each array. Okay. What would be our next step? How do we figure out who should go inside index 0 up there? Right. You compare orange, so the value pointed to by orange to the value pointed to by blue. You say, are you smaller than him? Nope. So who do I put inside of the array? Blue. Okay, so blue gets copied to array index 0. I increase this pointer, and I increase this pointer. So I increase those two index values. Then what's the next step? Compare this guy. So blue to orange again. Okay, you can kind of see a loop here. Compare blue to orange. If blue is less than orange, put blue into yellow. Okay, so 1 goes up here, right? Oh, shit. I did something very bad. Hold on. Yeah, they have to be sorted arrays. Yeah, this isn't going to work unless they're sorted. Sorry. I totally forgot. That's okay. We can still do this. We'll still make this guy 12. So more importante, they are already sorted. Okay. So then we compare blue to orange. Okay. Blue is smaller than orange, so what happens? The value at blue gets copied to the value at yellow. So you copy 13 here. And then what do? Increase the yellow pointer, increase the blue pointer. Okay? I'm not going to write out the whole algorithm for you. I'll leave that for you guys if you need to, okay? All right. What do we do again? Now we're looping. Compare blue to orange. Blue is less than orange, so we copy blue to the new array. Copy the value at blue pointer to this array. We increase yellow. We increase blue. We compare blue to orange again. Blue happens to be less than orange, so we copy the value at blue pointer. We increase yellow. We increase blue. Compare blue to orange. We copy that blue. We increase blue. We increase yellow.
Instead of incrementing both of them, could we just increment the one that gets put into the new array? That way we don't have to run through it repeatedly?
If you don't increase blue, you don't know where you are inside of this array. You have to keep track of where you are in this array, where you are in this array, and where you're adding the new value in that array. You do have to have the 3 pointers, or the 3 indexes. You got to keep track of those indexes. Now we've come to a point where we're comparing blue and orange, and who's greater? Blue's greater, so orange is less. So now we're going to copy the value at orange to our new array. So you copy the value at orange to the new array. You increase yellow, and now you increase orange. So whoever gets copied, that's the index value that you increase. You don't increase blue here, right? All right. Compare blue and orange again. Orange is less than blue, so we copy the value at orange. We increase yellow. We increase orange. Compare 78 to 59. 59 gets copied to the new array. We increase yellow, we increase orange. Now when are we going to stop? So 65 gets copied. When are we going to stop this? When do you think we're going to stop? No, we're going to stop ahead of that. We're going to stop before that, actually. So we're going to stop before the yellow pointer reaches the end because we have two arrays that are not the same size. So note we're going to run out of one of these arrays soon. So yellow gets moved, orange gets moved. So when are we going to stop? Yeah. Once we index out of one of our arrays, we will stop. So once either the blue or the orange have gone beyond the length of their array, then we stop and we start the next part of our algorithm, which is what? What should we do now to finish this up? Right. The array that has some left in it, you just copy those to the end. So whoever has, remember you're getting out of this first loop of the comparing. Okay, so you're no longer comparing anymore because he's out of stuff to compare to. So now you just take whatever's left in the array that has stuff left and copy it to that array. Okay, so you would just copy, 145. You increase, 156. You increase and increase, 180. You increase and increase, and 190. And voila! Now I know I'm finished. I know I'm finished when he has reached the end of his array, and he has reached the end of his array, and he has reached the end of his array. And then the yellow array is the array that you return. Okay, so everybody kind of got the algorithm. You can write out the algorithm if you want. Writing your code is like writing the algorithm. Okay. I'll let you work in programming pairs today, so you can work with a partner if you want to. This is due at the end of class here. I think you guys can hash it out. All right, here's what your method header should look like. I did give you your method header. It should return an integer array, and it should take in as parameters 2 integer arrays. So we'll just keep it with ints. It'll be easy. Okay. So you either have to finish the algorithm, you can just write out the algorithm and have it well written, or you can write your code, okay? But you got to get that done before the end of class today, okay? That's our class assignment. So hash that out. It shouldn't be that difficult.